This is a very basic introduction to trigonometry. The idea behind the ratios in trigonometry is the fact that when you have similar triangles, ratios of sides are equal. For example, I have two right angle triangles here, same size angles. The ratio of 3 to 4 is the same as the ratio of 6 to 8. Even though the sides are different lengths, we can still talk about the ratios, and the ratios are constant. Now, in order to work with these ratios, we have to have a way of talking about the sides. And what we do is this. If you're going to talk about this angle, which we're marking with the Greek letter theta, we have to have a way of talking about the fact that this is the opposite side to that angle. This is the adjacent side. It's next to the angle. And this, of course, is the hypotenuse. You've probably heard about that before. It's the side across from the right angle. Now, this is always the hypotenuse, but depending on which angle you're going to talk about, the other names change. You see, if I want to talk about this angle up here, this then becomes the opposite. And the side beside the angle is the adjacent. So make sure you know what angle you're going to work with first, and that's how you label the sides. Now we give names to these particular ratios. If you have a calculator, you've probably seen buttons that have SIN, COS, and TAN. Those are short for sine, cosine, and tangent. And these are names of particular ratios for sides in a right angle triangle. For example, the sine is the ratio of the opposite to the hypotenuse. So if you put that number over that number, you get the sine. Adjacent is the ratio of the adjacent over the hypotenuse. And tangent is the ratio of the opposite over the adjacent. Now, if you're first learning these, it may seem very confusing, and a lot of teachers give a memory device which consists of the first letter of each of these names. S for sine, O for opposite, H for hypotenuse. Same thing here for the cosine, adjacent over hypotenuse, and tan is the opposite over the adjacent. So a lot of students memorize SOHCAHTOA, and they use that to help them remember what trig ratios are called. Now, before we start with an actual example, make sure if you're using a calculator doing trigonometry, this is one thing you could do to test whether or not you're doing everything okay. First of all, make sure your calculator is set for degrees. Sometimes it could be set on something else. Make sure it's degrees. If you enter cos 60 and then equals or enter, you should get 0.5. Some calculators work in reverse. You have to put the 60 first and then hit the cos, and the 0.5 will come up. But play around with your calculator, see how it works. I prefer using a calculator where when you hit cos and 60, it actually, you can see it in the display and you know you've done it correctly, and then you hit enter with the 0.5. I think it's much easier if your calculator does it in the order that you write it here. Now, I've rewritten this SOHCAHTOA up here again so that we can refer to that. A typical question in elementary trigonometry would be to find the length of a side having been given another side and an angle. Now, the first thing you have to do is name the sides. This is the opposite. It's opposite to the 20. This is the adjacent. Opposite, adjacent, we're going to use the tan. Anytime you're not using the hypotenuse, you'll be using the tan. And we write it out this way. The tan of 20 degrees is the opposite over the adjacent, x over 12. Now this is fairly easy to solve. All I have to do is multiply both sides by 12. In other words, cross multiply. And on my calculator, I just enter 12 tan 20 equals. I don't even need a time sign there because the calculator knows that I'm multiplying by 12. So just enter 12, 10, 20, if you have a calculator that prints it out. Here's another example. Again, I have an angle and a side, and I want to find this side. Now, this time this is the hypotenuse, so I know I'm going to be using either the sine or the cosine. This is the adjacent, which means I'm going to be using cosine, because cosine is adjacent over hypotenuse. So once again, just as I've written over here, the cos of 30 is 15 over x. Now this one's a little harder because the x is on the bottom. I have to cross multiply to bring the x to the top of the left side, and then divide both sides by the cos of 30, and it looks like that. I usually just trade places with these guys. I put the x up here and the cos 30 down there. And then on my calculator, all I have to do is 15 divided by cos 30, enter, and that'll give me the length of x. In the second video, I'll look at the problem of finding an angle when you know the side lengths.